Quadratic Functions Part 7, Sketching a Parabola by Completing the Square. So this is a new way of sketching a parabola. Previously, we had sketched a parabola using factorisation, which meant first step was finding the roots, which meant solving the quadratic equation, then finding the turning point, which was halfway between the roots, also finding the y-intercept, and then doing the sketch. So this is a bit easier. So now we'll see that it's easier to sketch a parabola if the function is in completed square form. So that's what we're practicing recently. Now, to understand this, to begin with, you need to answer this question. What is the smallest answer you can get by squaring? So choose different numbers to square. So for example, 3 squared, that's 9, smaller than that. 2 squared is 4, smaller than that. 1 squared is 1, smaller than that. 0 squared is 0. We try it with negative numbers. Well, a negative times a negative makes a positive. So we actually get the same numbers there as we did for the positive. So the smallest answer we can have for squaring is 0. Now that's key to understanding the next bit here. So here's an example. Can we sketch the graph of y equals x minus 3 squared plus 1? Now that there is y equals x squared take away 6x plus 10, but in completed square form. So you would, you'd have the minus 6, which is minus 3. You would take off the 9 and then plus the 10, which gives you the plus 1. So how do we find the turning point of the completed square form graph? Well, notice first of all that this squared bracket is a positive squared bracket. Therefore, we're going to have a happy graph with a minimum turning point. For the minimum turning point, we want the y value to be as small as possible. We want the lowest y value. So what would we need to replace x with to make the squared bracket equal to nothing? We would need to replace x with 3. Because 3 take away 3 inside the bracket gives you nothing, and nothing squared is nothing. So x needs to be 3. So what does y equal when x equals 3? Well, there we've got what y equals. Substituting 3 into that, you take away 3 squared plus the 1. So the squared bracket obviously is 0, so you're just left with the plus 1, so y is equal to 1. So now what we've found is we've found the minimum turning point. We've found the lowest y value, which is 1, and that's when x is 3. So therefore, the minimum turning point is 3, 1. Separate to that, you want to find the y-intercept. Now, we did the y-intercept before, and this is just the same type of thing. Y-intercept, remember, is 0 along from the origin and then something up or down. So the x value is 0. So we substitute 0 in to the formula. 0 take away 3 squared plus 1. That means you've got negative 3 inside the bracket. So square that negative 3 gives you 9, and then add the 1 that's outside the bracket gives you 10. So therefore, the y-intercept is 0, 10. Now we can sketch the graph, draw your axes, and label your points. So there we've got 0, 10, and we've got 3, 1 for the minimum turning point, and that's to get the graph sketched. Another example, let's find the turning point first of all for this one. Let's say x plus 2 squared plus 3. So again, what do we need to replace x with to make this squared bracket equal to 0? Well, we need to make x this time be negative 2, because negative 2 then plus 2 gives you 0 inside the bracket, squaring that still gives you 0. What does y equal when x is negative 2? Well, substitute negative 2 in. and we get inside the bracket, obviously get 0 squared, 0, and then add on 3, so we get 3. Right, therefore, our minimum turning point is -2, 3. Let's get the y-intercept for it now. That's, again, 0 along, something up or down. Substitute x equals 0 in, we get 0 plus 2 squared, add 3. So inside the bracket it's just 2. Square that, gives you 4, and then add 3, 7. So our y-intercept is 0, 7. And now we can make a sketch of it. 0, 7, and -2, 3 on our graph. Now, do we need to go through all that process to get the turning point? Well, not really. We can state it without any of the working. So previously, we had these two. For the first graph that we did, we had 3, 1, and for the second graph, we had -2, 3. Let's have a look. We get -3 there, and that's +3. And then we've got +1, and that's +1. So what we have is the x value is the opposite number, and the y value is the same number, and you can see it in this one as well. +2, -2. +3, +3. So that's the shortcut. Shortcut is, for the turning point, the x value of the turning point is the opposite number when it's inside the bracket, and the y value is the same number as outside the bracket. So here's some examples. So inside the bracket we've got -4, so that means we're going to have +4, and then outside the bracket the same number, -5, so the minimum turning point is 4 minus 5. Inside the bracket for this one, we've got a +2, so that means it's -2. And the number that's outside the bracket's the same, remember, so that's -7. And the last one here, inside the bracket's a +6, so that means the coordinate is -6. And there isn't a number outside the bracket here, so you can say that that's 0. So just 0 is for your y value. One last thing that you'll be asked about is the axis of symmetry. So we did this before. The line of symmetry is a vertical line which goes through the turning point, and it's always x equals whatever the x coordinate of the turning point is. So in this case here, turning point x coordinate is 2, so that means our axis of symmetry is x equals 2.